So this presentation, I want to give some credit to my co-author, Chris Teutsch, who identified real early that we were going to need to work on some information for producers in forages as well as in row crops about strategies for improving fertilizer use efficiency so that we can get by with a little less fertilizer at the same time. We're trying to achieve all of our other objectives here. Yeah, let me see here if I can advance this screen. As of yesterday, the DTN does a survey, a retail price survey, and our prices that they were reporting are not quite as high as what I heard from your extension colleague, but they're still pretty substantial. They're up about 5% since last month, and they work out to be about between $1 and $1.07 a pound, depending on whether you're using urea or UAN. 55 cents per pound of P2O5 after you account for the nitrogen value in DAP, and 67 cents per pound of K2O for potash. In this context, we need to do a better job of improving our nutrient use efficiency. And what I'm talking about is trying to do better as we can at each of what we call the 4 R's: the right rate, the right timing, of the right source, with the right placement. I will admit to you that the 4R concept has largely been applied to row crops, but here I intend to use it in a pasture system with a little consideration for hay fields as well. And to do that, we have to consider not just the soil and the plants, but we also have to consider animals as part of this overall application. Most importantly is to grow the forage you need where and when you need it. There are times when you have good forage in a system, you don't need to stimulate additional grass production or forage production, and therefore it's not the time to apply fertilizer. And there are occasionally other considerations. We get improved stand or health, persistence of our stand in forages if we do a timely fertilizer application. And in some instances, we can improve the ability of our forages to compete with weeds. If we look at the way nutrients are removed from pastures, it's generally animal driven. With cow-calf grazing, nutrient removal in the milk and the meat is rather low. But other losses, depending on the pasture, the field, can be important. Those can occur in form of erosion, sometimes runoff, and almost always there's a form of chemical fixation where phosphate or potash particularly become unavailable with time. We can avoid erosion and runoff losses with a very robust forage stand that'll slow the water movement, and the plants that are growing tend to quickly take up soluble nutrients. This is an example that Chris provided me with. It actually partly emanates from John Laurie at the University of Missouri, where we look at nutrient cycling in these cow-calf systems. We have imports in the form of fertilizer, manure, legumes, of course, sometimes some feed supplements, and then we cycle these in and over again, and we get exports in terms of calves and beef. The nutrient removal on average for a cow-calf pair is about 10 pounds of nitrogen, 7 pounds of P2O5, and 1 pound of K2O per acre. So we're not removing a whole lot when we take this calf off of this pasture. We heard this earlier. I think this is the year where we're telling everybody, please start with a soil test. Nobody is telling you that soil testing is a perfect solution, because every field or every area within a field, if you're doing a little breaking up of your larger fields for separate sampling, is fertility unique. But we feel it is especially important to start with a soil test when fertilizer prices are high, because the main benefit of a soil test is to target lime and or fertilizer applications to pastures, hay fields with greater potential for an economic, a profitable response to that input. In Kentucky, we recommend a 4-inch deep sample. It may be different. I think it is different in Tennessee. I think it's 6 inches, but the bottom line is take it to the depth that's recommended, because that's what the fertilizer recommendation is going to be based on. And you need a composite sample of 15 to 20 cores from this area. And you need to get the depth right. Whatever depth you're responsible for, take it to that depth, because that's the most important step in the soil testing process, getting that representative area and a representative volume each time you take a core. You put them in a plastic pail, no galvanized pail, unless you'd like a really high value for zinc. And the bottom line is you mix it up real good and then fill your soil test sample bag to the appropriate depth. Now, this is a typical soil test report from the UK Cooperative Extension Service. And the first thing I want to look at is I want to look at soil pH. This particular example, which was taken from a alfalfa grass field, it's already in alfalfa grass, is a little bit low. And the recommendation was about a ton of lime per acre, but it's not bad. On the other hand, pH is the first thing I look at, because right now, for us anyway, ag lime is widely available. There have been no notable price changes in ag lime except in the delivery charges, because we've had some diesel fuel price fluctuations. And liming any acid hayfields or pasture soils is a very high priority, because we want to maintain optimal nutrient availability for the nutrients that are already in that soil. We also know that maintaining a good pH will help with forage legumes. We want numbers of plants to be adequate. We want their growth to be good. And we want the ability of the rhizobium bacteria to fix nitrogen to be optimal. And that's typically going to be optimized at pHs of 6.5 and above. We typically, for the clovers, like to see a pH of 6.4, 6.5, and for alfalfa, 6.8, 6.9. This diagram, which is euphemistically called the missile diagram, has a series of pHs along the bottom from 4 to 10. And the blue area denotes the area that, generally speaking, we like to have soils within that area, because you'll notice these missiles get wider within this blue area, and the width of those is proportional to availability. So these nutrients that are already in the soil, the P, the K, the sulfur, and these other ones, tend to be more available on average if you keep your pH of the soil within that region. The next thing that I take a look at is going to be soil test P and soil test K. We use Mehlich 3. So the real question here is, what's the level of adequacy? So you can see that in this case, the phosphorus was in the medium range, and the potassium was considered to be in the low range for an alfalfa grass stand. Soil test P and soil test K can be used to get to the right rate of P and K. Among the things that are easily adjusted, particularly in a forage situation, the rate is by far the easiest. You want to put what you need where you need it, and the soil test helps guide you in that way. The probability of a yield economical response is strongly related to the soil test level. What happens when the soil test is very low, maybe middle part of the medium range? Well, you've got a pretty good chance of getting a good response. Whereas when the soil test is mid, medium, and higher, you don't have as good a chance to get a response to P and K fertilizer. And when the chance is low and the prices are high, it's not as favorable an economic choice. This is an example of a diagram where we have over here the probability of a profitable crop response to fertilizer as a function of the level of soil fertility. And this would be regardless of the extractant. So when the soil test is in the very low to low region, you've got a really good chance of getting a profitable response, even to high-priced fertilizer. But when you get over here in the medium, particularly in the mid-medium range, up to high, your chances are much lower. Notice that even at high soil test level, you do have a small likelihood of a chance, for whatever reason, of getting a profitable response. So we're being fair to the data we have when we say, okay, it's not zero, but it's not high. So if you want to take the risk, you can put the fertilizer. On the other hand, you could also go to Vegas and bet there too. The table reflects what's in the figure just above it. High, less than 15%, medium plus 15 to 40, medium about 40% chance, medium minus 40 to 60, low 60 to 90, very low, greater than 90% chance. The reason these things happen in terms of these probability changes is because of the law of diminishing returns. And when prices are high, we in Kentucky are recommending not to apply fertilizer P or K when soil test P or K is medium in availability. This is the law of diminishing returns as applied to soil test phosphorus on the left and soil test potassium on the right. We have relative yield on the y-axis, and on the x-axis we have our soil test P or K. And notice in this medium range, the amount of relative response we're getting starts to get really small across. It's not zero, but it's diminishing as we get higher and higher. And the same thing happens with potassium. So what we're saying is in this medium range, we're worried that there won't be enough forage production to cover the cost of fertilizer that is recommended at medium test levels, at least in our state with our soils. So this is the region. Normally, UK would make some recommendations that, and we've started to cut these off in terms of what we're telling producers to do. Another reason is that the figure you see in the previous slide, those two figures are not, they're a smooth line, but it turns out they're an average of both responding and non-responding site. This is some old data with another extractant, but it illustrates this point very nicely. Over here on the left, we have fields that tested very low and low, and a lot of them gave a great response in the crop as fertilizer phosphorus was added. There were a few non-responders as we went to low. There were a lot more proportionally non-responders or slight responders as we went into the medium. And again, we're not zero as we're going into the high. We've got one or two responders as we're moving into the high range. And then there were some that were very high that gave no response at all. But this averaging is what you get, and then you get that smooth line on the previous slide. Hay fields are very much more nutrient extractant. You get much greater nutrient removal with hay production. This table illustrates some of those nutrient levels for the different kinds of forage crops that might constitute the hay you're harvesting. Alfalfa tends to be the neediest in terms of particularly potassium, among the neediest, but the grasses are interestingly more needy because you have to provide the nitrogen from them for them, either from the legumes that are mixed with them, or you have to apply it as fertilizer. And you can see there's a substantial amount of N, P, and K in every ton of these particular materials. So let's take a look at the soil test P and K for this particular example. We have P in the medium and K in the low. At today's prices, the phosphorus isn't terrible. It's 55 cents. Of course, you got to figure the nitrogen in the DAP, so it would be helpful if you could use it. So that's about 25 bucks. The potash is ugly. I mean, that's going to cost a couple $100 just to provide that K2O. So what can you do? Well, one thing you might consider doing is, particularly for hay fields, split this up. If you are in a 3-cut system, you might apply a third of this prior to each cutting rather than trying to put it on all at the beginning and risk losing more of it in the first cutting than what you need because you get luxury consumption in the alfalfa. What if the field was a grass clover pasture with a soil test P above 60 and a soil test K above 300? We make no recommendation for fertilizer when those soil test levels reach that high. We just say there's adequate here, adequate P, and adequate K. This is the area where UK, a lot of people aren't familiar with their soil test reports well enough to know this, but this is all maintenance fertilizer. There's a wide range in soil tests here. We've got P soil tests ranging from 41 to 60. That's 20 units, and it's all at a 30 pounds P205, or about 50 pounds of fertilizer. For this wide range in soil tests, it's another 30 pounds of K2O, but it turns out there was very little yield response in here. But when the older faculty and I was young at the time, we sat down and we looked at all this data. We said, look, soil test might be 41, but there may be areas of the field that are significantly lower. So one of the reasons we recommended maintenance fertilizer was to make sure for those areas that the soil sample didn't well represent, that were lower, that we could at least get some fertilizer on there, and that would help with the those low areas, bringing them up. But to be truthful, in the times we're in now, understanding that probably every university has some maintenance P or K built in right at the boundary between the soil test where they cut off fertilizer and the fertilizer and the cutoff below that is probably important for you to know. Maintenance fertilizer is often justified. I've heard a lot of producers say, well, I'm trying to put it in the soil bank account so the soil can maintain its fertility. The problem is the soil bank account doesn't pay any interest. You lose all the minute fertilizer hits the field. You have two options. You can recover it in an economically profitable crop, or you're going to have losses. You could have losses due to chemical fixation, erosion, runoff. All those kind of losses cause what I call negative interest. The soil never pays positive interest. There are a few cases where you can keep it close to zero, but otherwise it's just going to be negative. In fact, the chemical and the biological uncertainty, the biological kicks in with nutrients like nitrogen, sulfur, and a little bit phosphorus, tends to make the soil fertilizer bank a lot less valuable than dollars in the bank. And there's a lot of research that show applying fertilizer when it's truly needed to grow more of whatever crop you're growing, those are more efficient than doses of maintenance fertilizer applied, let's say, every year. There are some labs, this is an example, where it doesn't really matter what the soil test value is. They're going to recommend, usually at the request of the retailer that's providing free soil testing, they're going to provide a maintenance recommendation. In this particular example up here, we have phosphorus at 199 pounds per acre and potassium at 344. Now, UK would have cut this off to 0 at 60, and this one would have been 0 at 300, even if the crop was corn. The crop here is corn. Notice there's a 60 pounds P205 phosphate recommendation on this and an 80 pounds potash recommendation. Total cost of that is pretty close to $100 an acre. $100 an acre that recommendation would have that we wouldn't have. Let's talk a little bit about timing. I know it's probably a little bit late to be talking about lime timing because, frankly, if you had an acid soil that was a problem, lime needs time to neutralize that. But if it's acid enough, then it's still good to get it on in the late winter, early spring, when you can get over a field without rutting it. Poultry litter, again, you have to be careful not to put it on too early. You can put it on later, but again, it still needs to be timed in such a way that the organic nutrients, N, P, and S, can be biologically mineralized to be made available to the growing crop. Soluble fertilizers, particularly nitrogen, should be on time. You don't want them to be too early, or you could have losses before the crop uses it, or too late. The crop could be getting too mature and the nitrogen doesn't give you the kind of growth and value that it could. Warm and cool season grasses have different seasonal growth habits, different optimal soluble nutrient, particularly nitrogen application timings. This is an example growth pattern that I got from Chris Teutsch. We have both tall fescue growth pattern here and Bermuda grass. So you got a cool season and a warm season grass. If we look at the cool season grass, it has an earlier growth habit and needs nitrogen earlier in order to maximize growth. Now, there's a caveat here. If you've got a history of clover in this field and a history in the pasture of good manure distribution, you may not need this first application. You may want to wait to time it for later because you want to graze off all that and you don't need more nitrogen, creating more grass than you need. On the other hand, if you want to stockpile that fescue, you may need a nitrogen application later in the year, late summer, early fall, in order to stimulate, use water that you get in the fall and stimulate some grass growth in the fall that you're going to either use or stockpile for later use. On the other hand, Bermuda grass has a totally different timing and a totally different behavior. It's got a need for nitrogen. Bermuda grass responds very well to nitrogen, but again, it has to be late, mid-April, sometime in there. Again, depending on how much other nitrogen is in the pool, it may be spread out later in order to just peak out that grass growth for that use by the animals or for hay. The question mark clear over here on the right is occurring because Dr. Teutsch and I noticed that in our environment in Western Kentucky, even though Bermuda grass grows totally dormant, fescue typically doesn't, although it's been cold these last 2 or 3 weeks, so we're probably not getting much biological activity. But we are experimenting with some late nitrogen phosphorus applications here in late November, early December. And what we're trying to stimulate with this is we're trying to stimulate the fescue to have more tillers and be in a better position for early growth next spring. We're in the second year of an experiment on this. We got this idea partly from the turf industry, where it's used somewhat, and partly from some earlier work done at Virginia Tech. Urea is probably the most common nitrogen fertilizer used in forage production in our region, and it has a problem with volatilization. We need to avoid those losses any way we can. The losses are driven by the urease enzyme, and the urease is typically found on leaf and residue surfaces. And when it's moist and the ambient conditions are warm enough to act so the enzyme can be active, and you have breezy weather that pulls the ammonia away as the enzyme processes urea. So these are really ugly in terms of getting losses. Now, when it's colder, typically prior to May 1, you don't have to worry about this quite as much. Or if you know that you're going to have a ½ inch of rainfall within 72 hours, you can avoid, because the rain incorporates, it dissolves and incorporates the urea, you can avoid using a urease inhibitor. But if you've got a lot of acres to cover and you're worried about volatilization losses, then you might want to consider a urease inhibitor. Now, urease inhibitors are kind of products where many are called but few serve. Those that are best are usually involve a molecule called NBPT or agritane. Now, agritane has gone off patent, so there are some good products that have NBPT. There's also a new product from Koch called Duramide or Anvol that's a good product. But there are a lot of other things on the market that say they're going to inhibit volatilization, and then when you check it out, they're not worth anything. When it comes to the right source, I still argue that pasture nitrogen and sometimes a fair bit of hayfield nitrogen is best provided by clover or alfalfa. In Kentucky, clover is by far the more popular choice for pastures, and we typically frost seed 6 to 8 pounds of red and 1 to 2 pounds of ladino clovers per acre, sometime around mid-February. Depends a little bit on the timing. You want to have the forage pretty well grazed off so that you want to have some good freezing and thawing to get good incorporation. We know that clover improves pasture quality and animal performance, partly by diluting toxic tall fescue. If you do use nitrogen fertilizer, I think Tennessee is similar to us. There is no good soil nitrogen test for that's in use. Our recommendations as our Tennessees are in a range. So you want to use the lower end of the rate range when you have prices that are as high as these are now. Remember again that nitrogen tends to drive grass growth in the pasture or hayfield. You want to be sure that all that forage is going to be needed, particularly in a pasture situation. In pastures, placement means more uniform nutrient distributions. In hay fields, we just want to make sure we get a good spreader pattern when we spread N, P, or K in the field. But in pasture, we have to manage the animals to cause them to more uniformly dung and urinate in these environments. We strongly recommend to get this better nutrient distribution that you use rotational grazing in summer, fall, and early winter, and then use stockpile plus bale grazing in fall, winter, and early spring. I do a bit of this latter. I do the former all the time, the rotational, and my wife and I do the stockpile and bale grazing later on in the year. But the thing that we have to do, because we have some wet natured soils, is we have to have a heavy use feeding area. And that means I have to have a manure spreader because I have to be able to take the accumulated manure out. And in my case, I spread it on hay fields. I want to say something about the value of good hay because right now it's different than what you might typically think. Good hay provides good nutrition to the livestock you're feeding it to. However, if it contains a fair, sizable amount of nutrients, managing it properly means you get good value from the additional fertility and plant nutrition that each ton of hay represents. My example here is a fescue hay that has about 50 pounds of N, 15 pounds of P2O5, and 50 pounds of K2O per ton. With forage crop recovery efficiencies, putting this out, bale grazing it, you could get roughly 30% of that 50 pounds of N, 80% of that 15 pounds of P2O5, and 100% of that 50 pounds of K2O recovered by the next forage crop, whether it's pasture or hay. And that equals another $56 a ton in value. So besides the value it has to the crop, to the livestock, it has value in those nutrients if you do a good job making sure those nutrients are well spread. We've been telling producers that reasonably priced hay may have a better value when well managed than high-priced fertilizer. It also helps, of course, if some of your neighbors are selling hay cheaper than they should be. I would be remiss if I didn't say there were some things that even as expensive as we hear prices are, that people are asking us about, hoping they will make a difference despite what is usually high cost. In the pH area, pelletized lime and suspension grade limestones are good products, not saying that, but they cost so much more per ton that you're still much better off spreading the appropriate rates of ag lime. Liquid calcium is listed here, but it probably isn't worth the space it takes to put those letters on the page. 1919 and 92330 aren't as valuable to you unless you need all three of those nutrients. You're better off with a custom blend that gives you the nutrients you want. By the way, in case you're wondering, 92330 is a 50-50 mix of DAP 1846O and muriate of potash 0060, and they just blend them together 50-50 and increase the price by about 30%. Poultry litter is an interesting case. You can make a case for poultry litter if it's cheap enough. You can say, look, I don't need, maybe I don't need all that P. I just need the nitrogen and the potash. If it's cheap enough, you can get by with that. But again, you need to make sure you get a litter analysis and you have a soil test in order to utilize it effectively. We do not have a good soil test for sulfur, for copper, for iron, or manganese in the state of Kentucky. I'm not sure whether Tennessee has one for sulfur. They may have. And therefore, we don't recommend any of these nutrients without a supporting plant tissue analysis because of that. Another thing we've seen are these fertilizer replacement products that are either low analysis or they're microbial. Frankly, they're too good to be true, and therefore they're probably not true. It's mostly just snake oil. Again, liquid humic acid or humus or humates. I've been asked about these. It's really difficult for me to see how even a gallon of a product like this is going to provide any soil carbon relative to a soil that have, even at 0.1% organic matter, it has 2,000 pounds of organic matter per acre. I don't see how a gallon of a product like this should be expected to change that much. Another thing we've seen is these chemical or biological fertilizer additives that make fertilizer nutrients more available. We haven't seen any of these that work. The inhibitors work because they're trying to protect the nutrient that's there. But adding things that are somehow going to make those nutrients more available, we haven't found any of these that have proven effective. This is a specimen label from a product, has a pretty good analysis, 1185. But if you look at the recommendation, let's say for alfalfa, you're only going to put on 1 to 2 quarts per acre for a cost of 10 to 20 bucks an acre after each cutting. So if you're in a 4-cut system, you might get up to, 1 to 2 gallons per acre. Well, what's in that? Well, 2 quarts weighs 5 pounds. And if you look at 11% of 5 pounds, it's going to be about a half pound of N, 0.25 pounds of P, 0.4 pounds of K, and the rest of the micronutrients are too small to make mention of. You could put on 10 full gallons of this product, which is quite expensive, and you're still only going to get about 5% of the total nutrient demand of most of the crops that we grow, less for alfalfa. So I'm going to close with a few take-home points here. I think the most important thing we can do is do soil testing because the data is really critical to nutrient management. I think where lime is needed, it's a very important thing to apply because, again, it improves the overall availability of the nutrients you already have in that soil. It improves the value of your soil bank account. We're not recommending fertilizer P or K if the soil test P or soil test K is mid, medium, or higher until prices moderate. Now, that may not be for a while, and it may mean the next time you soil test that field, you need to apply some P or K. But it won't be like you've lost the opportunity to apply 30 because it won't be that kind of a drawdown. Soil test K changes, soil test P changes as crops are removed, but they don't go down pound for pound. So it won't be like you have to make it all up. It is better to time these applications to optimize either the cool season or warm season forage growth. We need to do what we can to avoid urea volatilization losses of ammoniacal N contained in that. And I think a frost-seeded clover is a better source of nitrogen, particularly in pastures. And if you must use nitrogen, at least in Kentucky, we have a range, so we'll recommend you move to the lower end of that range to be sure you need that forage that you're growing. We're strongly recommending to improve dung and urine distributions that people implement rotational grazing. Feed hay on pastures with low soil test values and move the hay feeding points around the pasture, unroll the hay, whatever, to improve nutrient distribution. And also, let's avoid products that really are too good to be true, promise great availability for small nutrient amounts as a substitute for the larger amounts of fertilizer and lime that the plants truly need.